You feel like a programming fraud because you are actually doing your job better than ever before. That sinking feeling in your chest, that sense of being an imposter who doesn't truly understand what they built, is not a sign of failure. It is the specific cognitive dissonance experienced by senior engineers as their role shifts from writing code to managing complex system constraints and AI behavior. When you stop counting lines written and start orchestrating hardware limits and probabilistic models, your old metrics for success vanish, leaving you wondering if you are still an engineer or just a manager of black boxes. Today, we use data to reframe this anxiety not as a personal deficit, but as the necessary tax on evolving complexity in the AI era. The evidence suggests that what you are feeling is systemic rather than individual. A comprehensive study published at ICSES 2024 surveyed 624 engineers across 26 countries and found that 52.7% experience frequent to intense feelings of imposter syndrome. This statistic alone proves the phenomenon is widespread, yet it often feels like a private shame because you assume everyone else has mastered their stack perfectly. The data reveals that this anxiety correlates strongly with reduced perceived productivity rather than actual skill loss. You are not becoming less capable. Your environment has simply changed faster than your internal validation system can update. When we look deeper at the mechanics of how engineers process information, we find a clear explanation for why you feel stuck. Research using eye tracking and biometric data on final-year computer science students shows that those with high imposter feelings spend significantly more time reviewing code snippets but solve problems at a lower rate than their peers without anxiety. This suggests your brain is entering a state of hypervigilance, consuming extra cognitive load trying to verify every line because you no longer trust the abstractions around you. The feeling of fraud comes from this mismatch. Your eyes are scanning for errors that do not exist in the traditional sense, while your hands are busy managing trade-offs that have no single correct answer. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. For senior practitioners today, the root cause is often a shift away from deterministic logic toward probabilistic system design. As generative information retrieval evolves into information synthesis and RAG pipelines, engineers move from writing code to curating model behavior. You are now responsible for understanding GPU utilization, latency trade-offs between TPU clusters and GPUs, and how to mitigate hallucinations in production systems. This requires a new kind of judgment where you must know when not to write code is more valuable than knowing how to implement it from scratch. The black box nature of modern AI models creates an anxiety gap because you cannot trace the logic flow line by line, yet your ability to architect around these constraints defines your value as a senior engineer. The irony is that if you were still writing every single line of code yourself, checking syntax and debugging individual functions in isolation, you would likely be operating at a junior or mid-level capacity. The anxiety arises precisely because you have outgrown the role of pure coder. You are now an architect managing high-level system design where success depends on judgment rather than syntax correctness. Your worth is not defined by how well you remember the transformer architecture internals, but by your ability to select the right hardware for inference, balance costs against performance, and ensure reliability when models behave unpredictably. This transition creates a cognitive gap that feels like fraud because you are no longer measuring success with ruler and pencil metrics. Despite this clear signal from the data, many engineers try to fix this feeling through traditional upskilling or formal coaching programs. However, a quasi-experimental study presented at Chase in 2026, testing structured interventions on early career and senior staff, found that these focused psychological fixes only yielded modest results in reducing imposter scores. In fact, natural team collaboration and temporal factors often improve confidence more than targeted therapy sessions or isolated learning spikes. This implies the feeling is a reaction to the engineering environment itself rather than an internal deficit requiring a personal fix. Trying harder on your own will not resolve the dissonance because the problem lies in how you measure value within a culture that still rewards old-school coding speed over modern system orchestration. The data also highlights distinct demographic patterns, showing that women report higher rates of imposter feelings at 60% compared to men at 48.8%, with specific groups like Asian engineers reporting even higher prevalence near 67.9%. This variance suggests the phenomenon is heavily influenced by workplace culture and systemic expectations rather than individual capability alone. If you are feeling this way while your peers do not, it may be less about your technical knowledge and more about whether your current environment normalizes the complexity of modern AI engineering, or if it continues to demand impossible standards of total control over probabilistic systems. To resolve this cognitive dissonance, you must reframe your value proposition immediately. Stop trying to upskill your coding speed to cure this feeling because the data shows that coaching and self-optimization techniques have limited impact when the root cause is a mismatch between old success metrics and new engineering realities. The anxiety is simply the signal that your career has successfully outgrown the role of a pure coder. Your expertise now lies in understanding hardware costs, managing model behavior under load, and making architectural decisions that balance performance with budget constraints. You are not faking it. You are operating at an abstraction level where judgment replaces rote implementation as the primary currency of value. The path forward is to create environments within your teams where admitting uncertainty becomes a standard part of system design exploration rather than a sign of weakness. Since formal coaching shows limited efficacy compared to natural team collaboration, confidence grows through shared problem-solving and temporal adaptation. You must accept that in the AI era, not knowing exactly what happens under every layer of abstraction is not ignorance. It is a necessary adaptation to high-level system orchestration where you are managing capabilities rather than just implementing logic gates. The feeling of fraud is simply the tax on complexity for those who have moved beyond writing code and into designing systems that shape how intelligence behaves at scale. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.